all head full. Roger, SI-1, welcome home.
Imagine you are a visitor from another world, peering down on this planet we call Earth. Somehow the name doesn't quite fit, because the surface of the planet is just over 70% water and only about 30% land. So why name it Earth? Wouldn't ocean be more appropriate? Surely you think so much water on one planet has consequences. One upshot is that the climate seems unusually mild given the planet's position to the sun. Double checking, you confirm that the mass of water on this planet is helping to absorb the heat of the sun. That energy is converted into wind and water movements, creating this planet's climate and weather. Next, you pick a patch of ocean at the southern tip and begin to look for signs of life. Suddenly, a massive whale reaches the surface of the water. It's an incredible sight. The animal seems impossibly large, 15 meters in length. And you wonder how the ocean could nourish a creature of this size. Investigating further, you discover that, amazingly, this 15-meter whale is feeding on tiny organisms called krill, each barely 2 centimeters long. Here, the krill are feeding on single-celled organisms that adhere to the underside of the ice. The story of humanity is inevitably wrapped up in our relationship with the ocean. The ocean has always been a source of food, a way of traveling, and more recently, an energy resource. But even given this long and absolutely crucial relationship, what do we really understand about how the ocean works? Well, beaches represent an interface between land and sea, and they can be highly varied in their morphology, typically as a function of the prevailing winds and the wave energy. Some beaches directly face the open ocean, and so they will be exposed. Others will be tucked away at the back of estuaries or lagoons or long convoluted bays, so are more sheltered. In areas that are extremely exposed, there's a high amount of wave energy. This will often act to keep finer sediments in suspension. Every time they try to settle, they'll once again be lifted up into suspension. In some places, seaweed beds can be extensive. Picture, for example, the kelp beds off California that act as a unique protective habitat for so many other species. However, although seaweeds can be locally important, they cannot match the productivity of the millions and millions of single-celled algae. Yes, they look like plants, but in fact, they are quite different from plants. Why are the oceans so salty? The answer lies in runoff from the land. As our rivers run over the rocks that make up our continents, they partially dissolve those rocks, putting the chemical constituents into solution. And as the truism says, all rivers lead to the ocean. So over a very long time, our oceans have become salty, around 35 parts of salt per 1,000 parts of water in the open ocean. Krill act as the keystone species for the Southern Ocean ecosystem. There are other zooplankton present, but krill dominate. Given its importance, some researchers are extremely concerned about the sustainability of krill fishing in the Southern Ocean, the yield from which, for the most part, becomes fish food in various aquaculture projects. If we destroy the krill population, much of the Southern Ocean food web will also collapse. Both green and red algae are commonly found in the intertidal zone, in multicellular forms we call seaweeds. You may have seen what we call sea lettuce on a beach somewhere. That is an example of a multicellular chlorophyte. And perhaps if you live in Northeast North America, you may have eaten dulse, which is a multicellular rhodophyte or red algae. Some red algae can even produce calcareous deposits that allow them to persist in highly dynamic environments. Confusingly, we refer to these species as the coralline algae, even though they are not coral. At the surface, in the photic zone, light is not limited, and so, to an extent, in this zone, fish can depend upon vision to sense their environment, although in highly turbid conditions, vision is limited. At depth, in the aphotic zone, there is no light. And in this situation, natural selection has come up with a fascinating and very beautiful solution, that of bioluminescence. In short, if there is no light, you make your own. This is done. Sharks look strange, intimidating, sinister. They appear to prowl. The shape of their teeth is the stuff of nightmares. And they are large, extremely fast, and very efficient predators. Similar to the baleen whales, feeding on tiny plankton does not seem to restrict the size of these animals. The largest basking shark ever caught was over 12 meters long, and the whale shark, the largest fish in existence, can perhaps reach 14 meters. The deep-dwelling megamouth grows to 5 meters in length, and the majestic manta ray can be 7 meters in width. Each of these species uses modified gill rakers to catch their prey, and the manta ray even has an extra set of modified fins around the mouth called cephalic fins, which help direct the flow of the water into the mouth and out of the gills. All of these species still have. When you watch a penguin dive, darting to and fro under the water, it emits a trail of bubbles. This is not some artifact of a hidden propulsion system, but simply the trapped air being squeezed out of the feathers by the pressure of the water. The minute the penguin enters the water, to an extent, the clock is ticking, although as we shall see, penguins have other ways of staying warm. On land, the air is trapped in the penguin's feathers, acting as an insulator. This is particularly important for chicks who are somewhat lacking in the internal layers of fat that they need to stay warm. King penguin chicks, for example, are sometimes fond. We know that it's highly complex and slowly changes within a season. Of interest, we also know that only the males sing, and by some unspoken arrangement, they all sing the same song. Whenever only one of the sexes is involved in a behavior, it is usually an indication of the behavior's use in courtship or mating. Because of its complexity, the humpback's song is presumably difficult to perform. We used to believe that humpbacks would use the song to advertise themselves. Researchers speculated that the animals sang. But let's think a little bit more about how we know what an animal is feeding on. In a very few cases, we can witness a successful ingestion event. This is particularly true of semi-terrestrial predators such as polar bears feeding on various species of seal, or a sea otter lying on its back using tools to crack open a juicy bivalve. However, for marine mammals, more often than not, the ingestion event occurs below the surface. Different species of baleen whale have different filtering abilities. This represents an extraordinary adaptation that is worth thinking more about. How does a humpback whale, for example, swallow its prey? I've already talked about lunging. In that act, the animal engulfs a huge mass of water and prey. But remember, the whale just wants the prey. That act of engulfment causes the ventral pleats to expand to accommodate the large volume of water. Remember, the humpback is a rorqual and thus has that ability. Then the mouth closes and the tongue at the floor of the mouth starts to move upwards towards the roof of the mouth, essentially acting as a gigantic hydraulic press. Mechanically, it is quite a challenge. The mother appears capable of pumping the milk from one of the two teats either side of the genital slit. Calves must be quite dexterous in establishing a hermetic seal with the nipple. Little is known about how they do this, as we have very few close-up visual accounts of the event. Listen carefully to this song. You will hear the repeated units within a phrase. In strand feeding, an orca will sprint swim onto a beach, perhaps using slightly deeper channels that allow it to approach and enter the swash zone while still immersed. In this way, they can charge onto the intertidal area and grab an unsuspecting sea lion pup that presumably thought it was safe as long as it remained out of the water. Having deliberately stranded itself on the beach, the whale will then use a combination of wriggling, side-to-side tail thrashing, and even the return wave caused by the initial charge to help return it to the water, still holding the pup in its jaws. They advertise that the ice hole is open to prospective mates by singing underwater, a song that has to be one of the most bizarre vocalizations I have ever heard. You would think it were being made by a synthesizer, something out of Star Wars. But nonetheless, this vocalization is made by the Weddell, and it is so loud it can sometimes be heard above the ice. Another example of a land-based marine mammal is the polar bear. Polar bears are intimately tied to the sea ice of the Arctic, where they find their prey, seals. While they will occasionally come to land and sometimes forage on berries when no other food is available, for the most part, they live on the sea ice and can potentially have immense ranges or territories over thousands of square kilometers. Again, just because when you look out to sea and all you see is water, remember that underneath the water, in the water, on the seafloor, and in the seafloor is a vast variety of life. This should not be surprising. As I have shown, we are fairly confident that life evolved in the ocean, perhaps on the sides of those black smokers. So if you think about it, we've had almost 4 billion years of evolution and natural selection to create the diversity we see. No wonder we are so attracted to it. As Ishmael puts it in the opening paragraph of Melville's Moby Dick, if they but knew it, almost all men in their degree, sometime or other, cherish very nearly the same feelings towards the ocean with me.